the remaining integer exponents so that the product of a power rule and the quotient of powers rule continues to apply. So for any number that's not 0, we have to define x to the 0 to equal 1, because that's what it takes to be consistent with the product of powers rule and the quotient of powers rule. If we have x to the 0 times x to the n, that has to be x to the power 0 plus n, which is just x to the n, which is 1 times x to the n. And so x to the 0 ought to be equal to 1. If we have x to the n divided by x to the n, well, according to the quotient rule, that has to be x to the n minus n, so that has to be x to the 0. But anything divided by itself is always 1. And so again, to be consistent, x to the 0 has to be 1. And you can see why this doesn't necessarily work when x is itself 0, right? Because anything times 0 gives you 0, and we can't do 0 divided by 0. We define negative integer exponents as follows. For any non-zero real number, x to the negative n is just the reciprocal of x to the n. And this lets us simplify the statement of the quotient rule. For any integers m and n, x to the m over x to the n is always equal to x to the m minus n, which is a positive number if m is greater than n. And it's also always equal to 1 over x to the n minus m, which is n minus m then is a positive number if m is less than n. Okay, so we've just seen a whole bunch of exponent rules, including the definitions of 0 and negative integer exponents. Let's just see a couple examples where we apply those. If we take x to the 3rd power times x to the 4th power, that'll be x to the power 3 plus 4. We add the exponents, so that's x to the power 7. If we have x to the 7th power over x to the 3rd power, well, that's going to just be x to the power 7 minus 3, which is x to the 4th power. If we have x to the 5th power divided by x to the 8th power, well, there are two approaches we can take here. We can say x to the power 5 minus 8 is x to the power negative 3. Or we can say, okay, x to the 5th power over x to the 8th power. That's 1 over x to the power 8 minus 5. So that's 1 over x to the 3rd. And because we defined negative exponents the way we did, those are equal. Okay, here we have a power of a power, x to the 3rd power, all to the 5th power. We have to take x to the 3rd power, and then 3 times 5. So that'll be x to the 15th power. If we have x to the negative 3rd power to the 2nd power, well, that's going to be x to the negative 3 times 2. So that's x to the power negative 6. And we can just leave that way, or we can rewrite it as 1 over x to the 6th. If we have 4 times x to the 3rd, well, that's 4 to the 3rd times x to the 3rd. And 4 to the 3rd we can actually work out. We can do that by hand, just over in the margin here. 4 to the 3rd is 4 times 4 times 4 is 16 times 4 is 64. Or, of course, we can do that on a calculator. 64 x to the third. If we have x over 3 all to the fourth power, that's x to the fourth power over 3 to the fourth power. And 3 to the fourth power, again, we can work that out over in the margin. 3 to the fourth, that's 3 times 3 times 3 times 3. That's 9 times 9, that's 81. Or, of course, we could do that on the calculator. Either way, we get x to the fourth over 81. One more. We have x to the negative 2 over x to the third, all to the power negative 5. Well, that'll be x to the negative 2 to the power negative 5 over y to the third to the power negative 5. That'll be x to the negative 2 times negative 5 is positive 10 over y to the 3 times negative 5 is negative 15. And then 1 over y to the negative 15 must be y to the positive 15. So this is finally x to the 10 times y to the 15.